Hello, Algebra. So, just to let you know, this is the third time I am attempting to record this. I have recorded it two or three times through already, and none of them saved. So, I will still try to keep it as short as possible. But just so you know, this is the fifth time I've run through each of these problems. All right. So, we're going to be looking at 2.6b. We're still in Standard C, and we're going to look at word problems that have to do with ratios and proportions. So those definitions I gave at the end of the last video will pop up today. So let's just dive right in. First one, Jenny ran the first 6 miles of a marathon in 58 minutes. If she is able to maintain that same pace, how long will it take her to finish the 26.2 miles? All right, so what we're going to do is we're going to make, from these word problems, we're going to make proportions. So I see one ratio in here. 6 miles in 58 minutes. So to write that as a proportion, I'm going to write miles over minutes. So 6 miles over 58 minutes. I will tend to do time on the bottom. If you think of like miles per hour, that would be miles per hour. Hours would be on the bottom. So I typically put time on the bottom. That's just me. So we have one ratio, but this is not a proportion, right? We need to find something that's equal to it. And what we're going to do is we're going to use what we're trying to figure out to write that other proportion. So if she's able to maintain that same pace, when you see pace, okay, that's rate, right? So this right here is a rate. It is two different things with different units of measure being compared. 6 miles and 58 minutes. So she's going to keep this rate, okay, it's going to stay equal, but how long will it take her to finish the 26.2 miles? So now we're looking at 26.2 miles, and we're wondering how long, how many minutes. Units are minutes. Notice, to figure out how, where to put each value in your proportion, make sure your units line up across the way. Don't be mixing them. That'd be like flipping a fraction just because. Can't do that. So we're trying to find minutes, so I'll put a variable in there for minutes. And now I solve this proportion. To solve it, we're going to use cross products. So I'm going to do 6 times y, which is 6y, equals 58 times the 26.2. So first I'm going to do the 58 times 26.2. So I still have the 6y, and that would get me 1,519.6. Still trying to find y's. I'm going to do the multiplication by 6 by dividing by 6 and do that on both sides. I'll get y equals, well, when you put this in your calculator, you're going to get something with a lot of decimals. So I'm going to round. I'm going to use a squiggly equal sign. That means about or approximately. So y is approximately 253.3. All right, if you round, you need to tell me you're doing that by putting approximately, because this does not, y does not equal exactly this. It's about this, we rounded. Is this my answer though? No. How long will it take her to finish the 26.2 miles? Y is about 25.3 or 253.3. That's not an answer to this question. So what we have to do is we have to say, okay, it takes about 253.3, and then don't forget your units, which are minutes. So you just take your value for y, put it back in here, and you have 253.3 minutes. Let me just write it out. Not too bad, right? Let's do another one. The Be Clean car wash washed 128 cars in 3 hours. At that rate, how many cars can they wash in 8 hours? So we have a rate, 128 cars in 3 hours. So our ratio is 128 cars, 3 hours. All right, how many can they wash in 8 hours? So we know we're looking at 8 hours, how many cars? So I'm going to put a variable for the number, and I have my unit cars. My units line up, so I'm good to go. Again, I'm going to cross multiply. 3 times x equals 128 times 8. All right, keep the 3x for now. 128 times 8 That's 1,024. And now I'm just solving for x. So to undo the multiplication of 3, I divide by 3, and I do it to both sides. Those 3's will cancel. I'm left with x equals, all right, if you do this in your calculator, you'll get 341.33, a bunch of 3's repeating. Remember this notation. The bar goes over the decimals that keep repeating. So the 3's all keep repeating, so I put a bar over the 3's. All right, is that my answer? No, they want to know how many cars. So you can't really have 0.33333 of a car. So I'm going to round down, be conservative with it. So it's about, right, I'm rounding, so about 341 cars in 8 hours. And that would be my answer. And with these, you can always check by plugging in what you get for x or y back in here. If you round, though, you're not going to get exact amounts, okay? So you want to keep that value in your calculator and then work backwards from it, which can be kind of tricky. If you mention it to me in class, we can maybe talk about how to do that. For this last one, I encourage you to pause here and try it yourself. All right, and let's do it together. So, on a map of Florida, the distance between Jacksonville and Tallahassee is 2.6 centimeters. If 2 centimeters equals 120 miles, what is the distance between the two cities? Well, 2 centimeters equals 120 miles. What is this an example of? It's a scale. Talked about this yesterday. So a map is an example of a scale model, and we use a scale in a scale model. So for our scale model, this is our scale, and we can write that as a ratio. So for every 2 centimeters you would travel on a map, you're traveling 120 miles in real life. All right, so that's how it works on the map. We're looking specifically at Jacksonville and Tallahassee, and we know that on the map, it's 2.6 centimeters. We need to figure out how many miles. I'm going to use the variable z. Again, we're going to do cross products. 2 times z equals 120 times 2.6. All right. So keep the 2z. I'm not going to touch that quite yet. 120 times 2.6 is 312. Undo the multiplication by 2 by dividing by 2 and do it on both sides. Those 2's will cancel, and I'm left with z. 312 divided by 2 is 156. So, what is the distance between the two cities? 156. Our units is miles. So 156 miles. All right, not too terribly bad. You just need to be able to pick out those rates and create a proportion and figure out what your unknown is. So for the homework, do the 2.6b worksheet. All right, do 4 problems, any 4 problems that you want. If the instructions on Schoology are different, follow the instructions on Schoology, okay? Because maybe I changed my mind before this post. You can X out now if you want, but I'm going to talk about cross products just a little bit more right now, just to explain how cross products work. All right, so with cross products, we have 2 ratios that are, well, they might be equal, they might not be, okay? So let's see, 2 or 4 is equal to 1/2. All right, the reason we do cross products, okay, if this is equal, the cross products will be equal. We're going to use some things that we have talked about with solving equations. So I can multiply, like if I wanted to get the 1 by itself, I'd have to undo this division of 2 by multiplying by 2, and I'd do it to both sides. All right, so I have 1 equals, and I'm not going to multiply this yet. I'm just going to leave it as 2 over 4 times 2 over 1. Okay, and we can rewrite this as 1 equals 2 times 2 over 4, because 4 times 1 is 4. All right, now if I wanted to get the 4 to the other side, I would do 4, to undo this division by 4, I would multiply by 4, and I'd do it to both sides. So those 4's will cancel, and I'll have 4 times 1 equals 2 times 2. All right, isn't that just the exact same thing as cross products? If I come back up here, cross products here, I get 2 times 2 equals cross products here, 1 times 4. So cross products, what it's doing is it's doing all of these steps in one beautiful swift step. All right, just to give you kind of an idea of where cross products from, you don't just pull it out of a hat. This is something that is mathematically true. All right, so at this point, I am actually done. Enjoy the rest of your day.